In this video, I'll be introducing formula weights, the concept of the mole, and molar mass. In future videos, we'll be working extensively with formula weights, the mass of a substance, and the number of moles contained within a certain mass of that substance. Because of that, we're going to go through a short video in which formula weights are introduced. We take those formula weights and convert them into something called a molar mass, and we can use that molar mass to then convert between grams, the number of particles, and grams. The formula weight of a substance, sometimes called the molecular weight, is the sum of the atomic masses of the individual atoms in the chemical compound. Methane, for example, has 1 carbon atom and 4 hydrogen atoms. Its formula weight would therefore be the sum of the 1 carbon atom, 12.01 AMU, plus the 4 hydrogen atoms. Each hydrogen has a mass of 1.007 AMU, so you multiply that by 4. This results in a formula weight of 16.04 AMU. Quickly going through 2 additional examples, calcium chloride would have a formula weight equal to the sum of the calcium atom and the 2 chlorine atoms, which equals 110.98 AMU. Iron sulfate would have a formula weight equal to 2 irons, 3 sulfurs, and 12 oxygens, which equals 399.91 AMU. Formula weights are important as they provide us with the starting point for any quantitative work involving chemical reactions. As stated in one of the first videos of this series, the SI unit for amount is the mole. You can think of it as the scientist's version of 1 dozen. 1 dozen equals 12, so a dozen eggs equals 12 eggs. 1 mole is approximately equal to 6.022 times 10 to the 23. So 1 mole of carbon atoms is approximately 6.022 times 10 to the 23 carbon atoms. The number of objects represented by 1 mole is equal to a value called Avogadro's number, which is symbolized as capital N subscript capital A. So Avogadro's number equals 6.022 times 10 to the 23. The reason that formula weights in moles are important is they allow us to interconvert between the masses of a substance and the number of particles that you have in that given mass. An incredibly important relationship is that 1 AMU equals 1 gram per mole. This allows us to interconvert between masses and number of moles of a substance. If we report the mass per mole of a substance, we call this the molar mass. So methane, which has a formula weight of 16.04 AMU, has a molar mass equal to 16.04 grams per mole. This is because 1 AMU equals 1 gram per mole. We can use this relationship to interconvert between moles and grams. Using the methane example, we're going to determine the mass in grams of 4.30 moles of methane, and we're going to determine how many moles of methane are found in 4.30 grams of methane. When you go from moles to grams, you multiply the number of moles times the molar mass of that substance. So in this case, 4.30 moles times 16.04 grams per mole, the moles cancel out, and you're left with 69.0 grams. When you go from grams to moles, you have to take the inverse of the molar mass and multiply that by the mass. So 4.30 grams times 1 mole per 16.04 grams equals 0.268 moles. Doing these interconversions will come up again and again in future videos. And with that, we've reached the end of this video. The key takeaways are that the formula weight of a substance is equal to the sum of the atomic masses of all the atoms contained in that compound. 1 mole of a substance is equal to approximately 6.022 times 10 to the 23 particles of that substance. 6.022 times 10 to the 23 is a value we call Avogadro's number. 1 atomic mass unit is equal to 1 gram per mole, If you report the formula weight of a substance in terms of grams per mole, we call that the molar mass. To go from moles to grams, we multiply the number of moles of the substance by its molar mass, and to go from grams to moles, we multiply the mass of the substance in grams by the inverse of the molar mass. In the next video, we're going to apply these concepts when we talk about reaction stoichiometry. Earlier in this video, we talked about the fact that 1 dozen equals 12. You've probably also heard of a baker's dozen, which equals 13. An origin story for the term baker's dozen comes from the Middle Ages. One of the possible origins of the term baker's dozen is from the Middle Ages. Back in the Middle Ages, there was incredibly strict weights and measures. If a merchant was found selling something that didn't have the advertised volume, weight, etc., they could end up in the stockades or worse. The ingredients, temperatures, cooking time, and other factors that medieval bakers had to deal with were incredibly variable. Therefore, it was incredibly difficult for them to bake a loaf of bread that had an exact mass. In order to avoid being put in the stockade or other punishments, a medieval baker would often give an extra loaf of bread to their customers. Hence the term baker's dozen was born.